Hi, here is Abdul. Now we are gonna see something about Biot savart law. So, what is this law talking about? It is just a relation between a magnetic field and the current. So, just I would before going into the deep explanations, I would just like quick take a graphical view. Here is a connecting wire through which a current I is passing in the upward direction. So whenever there is a current carrying wire, we have a magnetic field generated around the current carrying conductor. So it is in the form of eccentric circles which is formed around the conductor. So now here it is very important to understand what is actually the magnetic field produced here, and what is the relation of that magnetic field with the current, and the direction of current and the angular distance between the wire and the magnetic field produced. So now, so just like as I said, there is a current passing through this wire. Due to this, there is some a magnetic field produced. I just want to make clear that electrical field and the magnetic field, they are just like two faces of a single coin. So just don't confuse. Wherever their electric field exists, there exists a magnetic field, and wherever the magnetic field exists, there exists the electrical field. So now, I would like to just tell you what exactly the direction of this magnetic field works like. Just consider, assume that I'm very poor in drawing. Consider this as my thumb, this is my nail. Okay, and yeah, this is my like four fingers, like in this direction. If you can see that this, I'm just facing like this. So this thumb direction is the direction of my current. Okay, and you're seeing this, my fingers coming out. This are like the direction of magnetic field which is coming out, and this is the direction of magnetic field which is entering. So it is like circular around the electrical wire. This magnetic field is rotating in a circular, forming the eccentric circles with center as the connecting wire and surrounded by magnetic field. So now, if we consider that here we are getting some output magnetic field, which we denote it like this, we are getting some output magnetic field thrown this side, and we consider that there is some kind of input magnetic field which we denote in this way, input magnetic field. At the other side, as you can see, it is entering and it is leaving. So we just consider this part, the upper part, like this. Actually, if you just consider it in 3D, it is just like this. This is my electric carrying conductor, and this, if you can see this is my direction of magnetic field, like this rotation, this rotation without touching, like it is forming some eccentric circles throughout the electrical conductor. This is my electrical wire, so I'm just like, this is my magnetic field around it. So just like the direction is, if the current is flowing in this in the upward direction, then the direction of magnetic field is this. If the current flows in the opposite direction, then the magnetic field direction will be opposite in this way, clockwise. Now it is anti-clockwise. So now, apart from this, now we are going to introduce, I don't want to make a derivation like how to derive by using integrations and cross and dot products. Rather, I will just prefer to give you a shortcut method where you just take magnetic field, you denote it by mu. It is some constant. I'm going to introduce this. I, this is a current, divided by 2 pi r. So rather than like going step by step derivation, I will just do some reverse engineering here. So I will just tell you that we are going to, this 2 pi r is nothing but the circumference of my eccentric circles which are formed around the electrical wire. So this this magnetic field which is produced around the electrical wire is forming a circle. So that is the circumference of a circle, 2 pi r. And consider some point here, some point which is connecting to the wire, and it is taken as distance r. So we consider it as 2 pi r, and this I is the current, and mu is permeability, and here in our case we take it as mu naught, because the free space between the magnetic field and the electrical wire is air. So permeability for free space is taken as mu naught. So I hope guys you got a relation. This is the magnetic field. So this magnetic field, the magnitude is directly proportional to current and permeability of free space, and it is inversely proportional to the distance between the point of charge and the electrical wire. So here we go.